first one is the set theory and Venn diagram. Now, on the Venn diagram, we have 3 diagrams. So you see that some of the circles, they intersect each other, some do not. Then there's a particular cell that intersects all of them. So now the set theory is just a branch of mathematics that is used for subsets. So when you want to look at the common subsets within different sets that we are studying. So basically we said here that a set is an aggregate class or collection of objects which are called the elements of the set. So we'll be looking at different sets and subsets. So here we have, in this slide, we have S1 as set 1, which has 2 and 4. And then we also have S2, that's set 2, 2, 4, 6, 2, 9, 2n. So, which is equals to all even integers. So if you look at the figures inside, they are all even integers. Then we have a third set, which is made up of x given x raised to the power square 6x plus 11 is greater than or equal to 3. And then we have another set, S4, which is equal to living Dales, so it's named John. So you see that each of the sets are comprised of different subsets within each other. So to get a more breakdown of this particular slide, please look at the reference on study session 1 in the material. So now when we talk about sets, one thing we normally use to represent sets is what we call the Venn diagram. So the Venn diagram shows a relationship between different sets of information. So like we have here, you say, put simply, a Venn diagram or set of diagrams shows all possible logical relations between finite collections of sets. So if you see here, you see a set that is englobing another set. Then you see another set that is intersecting each other. Then another set that is intersecting another, and then another set that is also intersecting each other. But there's a common difference among all of them. Now this one, you see that it says is AUB, meaning that A is a union of B. So when you talk about union, we're just saying that an addition of both sets A and B. Then when you talk of A with an arrow or a symbol that looks like N, B, it's just looking at the common sets within the two sets. You just look at only the common sets. While this one looks at a combination of both sets. And then you see this one that has B minus A, it's just a subtraction of A from B. That's why we have just the B area that is shaded, and then the A area that is not shaded. So for example, if we have R sets that is representing odd numbers from 1, 3, 5, 7, 9, you can say they are a subset of the set of whole numbers where we have 1 to 10. So the R is a subset of S because the values in R were picked from the set of S representing odd numbers within those sets. So then we have another example where we have if A is equals to 2, 3, 4, 5 and B is equals to 5, 6, 4, 5, 6, 7. Then A what is a question mark. B will give us 2, 3, 4, 5, 6, 7. So when you look at this properly, you see that this answer here represents a union between A and B. That's why we have complete sets of 2, 3, 4, 5, 6. Because it is representing a union of A and B. So a combination of both A and B can be found in this set. So this answer can be A without using symbol B to give you this. So the intersection of A and B consists of common elements. What we mean by common elements are elements that are common in B but are also common in A. If you look at this, you see that 4 and 5 are common in A and they are also common in B. So if we are looking at common elements, then we will say 4 and 5 is a common element between A and U. So this example here can be represented in this graph that has only the middle being shaded. So the middle is just saying there's a component of A that is also common in B, which is 4 and 5. So yeah, so this is the example. So we use names of people to represent this particular example. So if you see here, you see Kachi and the rest, Kachi up to Lade, no, up to David. So among your friends, you have the first 5 of them in your football team, and then you have another 5 counting from the back from David as members of your handball team. So you see that in this set, we have the names of people that are in football and names of people that are in handball. So when we look at a union between the two teams, we can have a union where the graph is representing everybody from football team and also everybody from the universal team. So that's what is represented by figure 1.2 here, which says a Venn diagram. A represents the football team and B represents the handball team. So it means that in set A, you will find the first 5 people, which is Kachi, Farouk, Mary, and Carol in set A. And then when you count 5 from back, David, Lale, Itse, Aishatu, and Chinyere will be set B. So that's basically what the Venn diagram represents. So you see that when you want to take a combined area of set A and B, which is called the union, we are going to be taking those in football team and add them with those in the handball team to get the union of A and B. So that's what that represents. So in summary, that's what you see in the slide.